Okay, hey, now I want to show you a really, really cool one. Let's take a look. So here I've got a circle centered at P, and I'm given this chord, RS. I'm given this radius, PQ. I'm actually told that they actually intersect at a right angle. And I'm told that this length here is 8, this length here is 2. And our mission is to find the length of RS. I want to find the length of this green chord. You know what? The reason why I love this question is because it looks like we don't have enough information. It looks as though there's no way to answer that. All we know is that they meet up at right angles, and this is 8 and that's 2. How are we possibly going to find that length? It seems like a great mystery, and that's why I love math, because it sounds like an interesting challenge. Once we look at things the right way, the answer is immediate. Here is the trick. The trick is to realize that I can draw in a radius wherever I want, and no matter how I draw the radius in, the length will be the same. Now, what's the length of the radius? We can figure that out, because we know this is 8, and we know this is 2, so the entire radius we know is 10. Now, that's not the radius to look at. Can you see which radius I should draw in? Well, I'm actually going to draw in 2. I'm going to draw one from P to R, and I'm going to draw one from P to S. Now, this is the key to the whole question, believe it or not, because we know that both of these have length 10. And since this is a right angle, we know that everything here is right. And so what we see here is that I have two triangles, and I see that I've got this side and this side being the same, and I see that I have these angles being the same. I see that this actually is the same as itself. And so what I'm seeing here is what? I'm seeing that these two triangles, in fact, are congruent. And so since they're congruent, I know that corresponding parts are going to be congruent, which means that, in fact, this length right here has to equal this length right here. Okay, that doesn't quite help me, but it tells me that if I could find this length, then I can get the entire length just by doubling it. Now, how can I possibly get this length right here? Well, look, it's a right triangle. I can use the Pythagorean theorem. I know this is 10, that's the hypotenuse. I know this is 8. I can figure this out now. Now, you can actually use the Pythagorean theorem directly, or you might actually remember one of my favorite right triangles. That's the 3, 4, 5 right triangle. A 3, 4, 5 right triangle, but this is a right triangle multiplied by 2. So here's the 4 multiplied by 2 is 8. Here's the 5 multiplied by 2 is 10. So this must be the 3 multiplied by 2 to give me 6. Use the Pythagorean theorem, we see this is 6. If this is 6, then this must be 6, and I see that the length of the segment RS, in fact, is 12. And I just think this question is so cool because it really allows us to see an issue that seems like we can't answer it. And the trick, and by the way, this is so important in so many circle questions, is to draw in extra things. No one told us to draw in those orange radii, and yet we did it, and the moment we did it, all of a sudden this right triangle came into focus and we were able to answer the question. That's the key to this question, and that really is the key to thinking about mathematics and geometry, is to be creative and add in yourself into the question in order to make the question go from impossible to really easy. Anyway, have fun thinking about circles, chords, and arcs.